Okay, before we start the make or buy, just a quick recap about the EOQ and the EPQ models. Okay, because in the make or buy, we're going to use both. And I think this is a good opportunity for you to reinforce what you have learned so far. So we can see on the yellow panel, the EOQ model, on the blue panel, the EPQ model, and we can see their profiles, how they are different. Okay, so let me just here say or re-emphasize one thing about the EPQ model, especially the EPQ model. Remember, I was saying before that the EPQ model cycle is split into two parts. Okay, so we have the first part is this. Why? What's happening in this first part? Here we are making and consuming, all right, the item that we want to satisfy. And in this, from this point until the end of the cycle, we are simply using the inventory on hand, right? That was the IMAX. So we are simply using what we have on hand without any new production. The new production will happen only when the second cycle or the next cycle will start again. All right. So I would just want to re-emphasize that. We use the EOQ model for a buy decision, and whenever we have a make decision, of course, the best way to do it is to make the optimal quantity. That's why we use the EPQ. Now, in the EOQ model, we receive the quantity at one time, and then we consume it at the rate D, while in the EPQ, we produce and consume simultaneously at the first part of the cycle, and in the second part we simply consume. We did not talk about the reorder point in the EPQ because in fact it's not a reorder, it's the time when we start making again, but we have already discussed that in the EOQ model. In the EOQ we reorder when we reach an inventory level equal to the reorder point, ROP. Remember, it was the quantity enough to satisfy demand during the lead time. Here we don't have it here in the EPQ, but we restart when we reach an inventory equal to 0. The maximum quantity on hand in the EOQ model is the quantity itself, the EPQ, while the maximum in the EPQ is not QP. Yes, we make QP, but we don't reach that level in our stock. Why? Because as we make, we are consuming. So that's why we reach a maximum of Imax. Remember, we build that at a rate of P minus U. And these are the equations that are used in the EOQ and EPQ. You can see their similarities and the differences between these two. Okay. Now that we have learned the EOQ and the EPQ models, we are able to make very, very important analysis faced very often by managers in real life, which is this. Shall we make or shall we buy? That's why this is known as the make or buy problem. It's a generic problem that requires the same type of analysis. And now you have a very powerful tool in your hands. What is it? It's your knowledge of how to use the EOQ and the EPQ model. So let's apply these. We are given the following. We have a firm that has an annual demand for a certain item of that much. They operate 250 days a year, and they have a holding cost given as a percentage. Remember the analogy between the holding cost and the investment. That's why this is given as a percentage. Now, if they want to order this item, this is the data available for them. And if they want to make it, this is the data available for them. And the question is, shall we make or shall we buy the units? So we will answer this question in the following slides. All right. In order to answer the question, of course, the analysis is based on the following. If we make, if we buy, we need to find what's the minimum cost of buying, and if we make, what the minimum cost of making, and then we compare compare both. And of course, we'll choose the option that have the lower cost. And we have learned from the EOQ and the EPQ that the minimum cost of purchasing comes from purchasing the optimal quantity, the EOQ. So let's find the minimum cost if we buy. Now you know that we have to find the EOQ. Here we go. Now you are familiar with applying this formula, but there is something that I need to highlight here for you. You can see here in the denominator, I'm multiplying 0.2 times 15. Why is that? Because in the previous slide, we were given the following information that the carrying cost is 20%. And we know that we cannot plug this cost here. This is not small h yet. This is the investment cost, 20%. That's why we multiply it by 15, which is the unit cost, the item unit cost. And this product will give us h, small h. And now we can use that in the EOQ formula and we find it to be 408 units. Now we are ready to find then the associated total cost, which we know that it's equal to the sum of the holding and the ordering cost. Plugging these figures here in the formula, we find that the total cost associated with ordering the optimal quantity is $1,225 per year. All right, what about if we want to make it? How much it will cost us? Of course, we're going to look for the minimum cost by finding the EPQ. So first we start by finding the EPQ. So we know that it's equal to a radical of 2ds over h times radical pp minus u. What do we have here? We know d, we know s, h we don't have it because we're given the investment cost, but we know from the previous calculation that it's sufficient to multiply 20% by the unit cost when we are making the item. Okay, and P and U, P is given, but U, we don't have the demand in the same time unit as P, so this is something that we're going to do next. U is the annual demand divided by the working days as we did before, so we find U to be equal to 40 per day, which is in the same time unit as we are expressing P. Okay, so here we go, it's 40 units per day. And now we are ready to use the EPQ formula. And here we go, we find it to be equal to 960 units. All right. You notice here that also, as we did in the EOQ, we multiply 20% by 13 because 13 is the unit cost when you want to produce every unit. Now to find the total cost, you know that first we need to find I max. All right, so I max is in relation with Q, so we find this easily to be 640 and we plug everything in the total cost formula. And here we go, we find the total cost to be equal to 1665. Again, remember to verify that these two terms are equal. By the way, in all our calculations, they are not exactly equal because of the rounding. But as we said, plus or minus 1 or 2, that's fine. We are still in the acceptable margin. And we finally find that the making will cost us $1665 per year. Okay, now that we have found the total cost of buying, total cost of making, so what do we do? Can we make the conclusion? Before that, ask yourself this question. Did you consider all the costs relevant to the analysis? You may answer yes, but I think you have missed one point. Why is this? What about the purchase costs? Remember in the first slides, we were given that it costs us $15 for every unit when you are buying, and it costs us $13 if you are making. So which means that in the two different options, the purchase cost is different. which makes this cost is a relevant cost for the analysis, and we have to incorporate it in our comparison. So let's see again. The total cost of buying, its holding cost plus ordering cost plus it's equal to DC. What's that DC? What's that DC? D is the annual demand and C is the unit costs. And what happens when you multiply the annual demand by unit cost? This is your purchase cost. This is your annual purchase cost. Remember when we were listing the components of inventory cost, we said the purchase cost is the highest cost. It represents maybe 90%, 95% of your total inventory cost. So putting it to this equation, and I'm calling it TRC. What's R? Relevant. We'll talk later why I'm now using this term relevant. So that makes our total relevant costs, if we want to buy $151,000 $2 to $5 per year. While if we make, because it cost us only $13 to make 1 unit, this is what will make most of the difference. Right? Again, here we are adding to the relevant costs the purchase cost, purchase of material, and the production cost. And that makes our option of making costing us $131,665 per year. And now if we compare, it's obvious that making is much more economical for us, which is different from the conclusion that we made when we omitted to include the purchase costs. We're going to discuss more the concept of relevant cost in the next session, which is EOQ with quantity discount. So I hope that this session was or this model was clear for you. I'll be available for you if you need any help.